Hey guys, welcome to the level 3 calculus paper from 2021 for integration. The way this video works is that I go through each question, let you guys know what you need to do for achieve merit and excellence. The best way to watch this video is to pause the video at the start of each question, have a go at the question by yourself, see how far you get along with it, and then unpause the video to check how I go about answering the questions. Anyway, without further ado, let's get started. Okay, so question 1A, nice, straightforward integration question. I guess this one you've just got to be kind of careful that you've actually got 3 over x there, and a lot of people tend to actually bring the x and put it as power of -1. Remember that whenever you're integrating and you have just x in the denominator, you will have to integrate it to ln, so don't forget that. So in this case, what we've got is x, we've actually got x squared over, so x over 3 first, and because it's raising the power by 1, so it's going to be 2, and then dividing by the new power which happens to be +2, plus 3 over x just integrates to 3 ln of x, and of course don't forget the plus c. Now in the answer schedule it actually says that plus c is not required. You know, and you can actually leave your answer like this. You don't really need to simplify it, but for those fanatics that want clean answers, they probably do this: x squared over 6 plus 3 ln of x plus c. Now this question is worth and achieved, and I'm fairly confident that you wouldn't need to do that 3 times 2 to, like, they wouldn't tag you down for that. So that is question 1A. Alright, so the question 1B, part A, what we've got here is gradient functions being given. As I was saying in the stream before, if sometimes when we see dy dx we automatically think differential equations, but in fact in this one it's just a straightforward integration here. So what we're going to do is we're going to write down dy dx, and we're going to write that x as a positive, sorry, not positive, we're going to bring it to the numerator with a negative power. Alright, so once that's done, now we're integrating both sides, which means when we integrate dy dx, we're going to get y is equal to 8x minus 3, and I've got plus 1, -3 plus 1 is going to be my new denominator, plus c. So what I've got here is y is equal to 8x to the power of -2 divided by -2 plus c. So what I generally have is y is equal to -4 x to the power of -2 plus c. Now unfortunately I need to actually find the equation of the curve if it passes through the point 1, 3. So the first thing is, what do we got? Let me just have a, so all it's really asking us to do here is just figure out what the value of c is, and we've got 1 and 3, so we're going to substitute 1 and 3 in this equation. So when we substitute 1 and 3, because our equation is y is equal to -4x to the power of -2 plus c, I am going to replace x with +1 and 3 with y. So I'm going to have 3 is equal to -4 to the power of times 1 to the power of -2 plus c, and I've got 3 is equal to, now 1 to the power of -2 is just 1, so I've got -4 plus c, and c is equal to 3 plus 4. So I've got c as 7, and therefore I can say that y is equal to -4x to the power of -2 plus 7. Now this grade is worth and achieved, and it looks like you need a correct solution with correct integral to get that achieved grade. So for this question we've got to figure out the area that's enclosed by the curve, right? The x-axis, lines x equal 1 and 2. Now what you can do, guys, is just do a quick graph on your calculator just to see what the graph actually looks like. So we've got -4 multiplied by x to the power of -2 plus 7. Okay, so it looks kind of like an ugly looking graph anyway, but like what does it actually look like if I zoom out a bit? Okay, so it's one of these weird looking curve things, right? And we're looking between 1 and 2, so it's like somewhere between there and there. So if we were to kind of like sketch this graph real quickly, it's probably going to look something like this, right? So that's your curve right there. And I guess 1 and 2, I mean, like, we kind of need to know. So it could be like 1 and 2 is like that. So without knowing that, so what I'm going to do is I'm just going to exit and I'm going to put another line. Y equals to 1, x equals to 1. So I'm going to put type, and notice how there's x equals to c. So I'm going to put x equals to 1. And you can kind of see that like it is, I'm going to zoom in a bit. There's that line when x equals to 1, and then this other line tends to be the graph. So in that case, going back to our diagram, we can kind of say that this is between 1 and 2. So we kind of need to establish that first, because sometimes you don't know whether the graph area is actually going underneath the x-axis, and if it does, then you need to separate the intervals, right? So we're going to go between 2 and 1, and our equation is negative 4x to the power of negative 2 plus 7, and of course we're going to put that dx there. All right, the next part is actually integrating this. So we're going to get negative 4x negative 2. We've got plus 1 to the power, negative 2 plus 1 in the denominator, plus 7x. And of course, we don't really need to worry about the c for this because we have a definite integral which is between 2 and 1. So we're going to get negative 4x to the power of negative 1 divided by negative 1 plus 7x between 2 and 1. And I'm just going to write this as 4x to the power of negative 1 plus 7x between 2 and 1. Now, you could be a little bit lazy and just put this in the calculator and get what the answer is. And I'm going to kind of do that anyway. And the reason is, and I want to show you guys this, right? Because what you can do is you could have actually gone into option, go into calc and integral and put in the equation. So we've got negative 4x to the power of negative 2 plus 7, and then our two limits, which happens to be 1 and 2. So when we do this, we get an answer of 5. Now, when I look at the answer schedule, right, because you could have actually just stopped at the second line because you've integrated it. You've shown that it's between 2 and 1, and you could actually go equals to 5. But I always play the safety one. The safety one is like getting up to this line here. So I'm actually going to write this as 4 times 2 to the power of negative 1 plus 7 times 2 minus 4 times 1 to the power of negative 1 plus 7 times 2. And I would say that we would pretty much get 4 over 2 and 14. So we've got 2 plus 14, take away 4 plus 7. So we've got 16, take away 11 equals to 5. So what you could have done is I probably would have done something like from here to kind of here, just substitute those x's with 2 and 1, and then I would have just written down the answer as 5. But I would always check the answers in the graphics calculator just to see that I'm actually correct there, because the reason is this is a merit question, and it's like you can get a merit fairly easily if you can just integrate, and then you don't, because you can easily make mistakes with the calculator. So that's why I always recommend this method for you guys, like put it in the calculator, get the answer first, and then make sure you integrate it correctly, and then put the answer at the end as well. So correct solution with correct integral will get you a merit. Correct integral will get you an achieved. So that's getting up to that part is getting achieved. But if you actually get to that part, you really should be getting a merit, because that's pretty much like the penultimate line that you need before you write down the answer anyway. So, you know, just get into the habit of like using the calculator to actually check your answers for these types of questions. Sorry, just made that mistake here. That should be 7 times 1. Let's try and change that out. Alright guys, so with question C, what we've got here is a classic kinematics question here. So remember that when we have acceleration, velocity and displacement, to go this way we've actually got to integrate, and to go the other way, so displacement to velocity, velocity to acceleration, you've got to differentiate. So with that in mind, we've got our acceleration, so we're going to put that down first. So acceleration of this object is 2 minus sine 2t. Now there's a couple of interesting points that's actually been given to us. We've been given some facts here. When t equals to 0, velocity is 1 meters per second and displacement of 3. So if we're going to write this in kind of formula, I guess, you can actually say v of 0 is equal to 1 and s of 0 is equal to 3. Of course, these things are going to come in quite handy because the question itself is asking what's the displacement of the object at t equals to 5. So the question is actually asking what is s of 5. So we're going to work through one step at a time. We're going to actually integrate acceleration, find out what the velocity is, integrate velocity, find out what the displacement equation is, and then finally we can actually work out what s of 5 is. So going through this, we can actually say v of t is integral of 2 minus sine 2t, which is going to give us 2t. Now negative sine, when you integrate it, you're going to get positive cos. So this is going to become cos 2t. But of course, you've got to divide by the differentiation of whatever that inside that cos function is, which in this case, differentiation of 2t is 2. And we've got to, of course, remember the plus c. So this is what the velocity function is equal to. But we know that velocity v of 0 is equal to 1. So we can actually use that to figure out what the first c value is going to be. So we're going to say, since v of 0 is equal to 1, we can say that 1 is equal to 2 times 0 plus cos of 2t. But of course, t is equal to 0 divided by 2 plus c. So when we do this, now we know that cos of 0 is equal to 1. 2 times 0 is 0, so we're going to get... what is it? Cos of 0, well, that's 0 plus cos of 0 is 1 over 2 plus c. And because of that, we can actually say c is equal to 1 minus half. Therefore, c is equal to positive half. So what we've got right now is the velocity function. Velocity function is equal to 2t plus cos 2t over 2 plus 0.5. Now we need to integrate this to find the displacement equation. So we can say that s of t is equal to integral of 2t plus cos 2t over 2 plus 0.5. So we're going to get s of t is equal to 2t. When you integrate it, we're going to get 2t squared divided by 2. Now cos, when you integrate it, you're going to get sine, so we're going to get sine 2t. Now this is the original 2. When I say the original 2, it's actually this one here. But I've got to divide it by the differentiation of whatever the bracket is, which in this case is 2. So I've got to add that extra 2 there. And of course, don't forget that this is also plus 0.5 t. Cool. So we can actually say s of t is equal to t squared plus sine 2t over 4 plus 0.5t. And of course, don't forget the plus c. We might not call it C, we can call it like another letter because we already used C before. So I mean, if you want, you can use C1, C2 if it helps. But yeah, I'm just going to use a different letter. Okay, now I need to figure out what the K is, and I know that S of 0 is equal to 3. So because S of 0 is equal to 3, I can actually say 3 is equal to 0 squared plus sine 2 times 0 over 4 plus 0.5 times 0 plus K. So I'm going to get 3 is equal to, this is equal to 0, sine of 0 is 0, 0.5 times 0 is 0, so I'm going to get K is equal to 3. So I have the equation for S of t, which is equal to t squared plus sine 2t over 4 plus 0.5t plus 3. So now I can actually work out what S of 5 is, because that's what the question is asking me to do. So I've got 5 squared plus sine times 2 times 5 over 4 plus 0.5 times 5 plus 3. All right, so we're just going to punch this in the calculator. So we've got 5 squared plus sine of 10 divided by 4 plus 5 times 0.5 is 2.5 plus 3, and all that gives me 30.36. Okay, so long question here. Definitely a very long question to just get a merit, but unfortunately that's all it's actually worth, because if you guys have a look here, it's correct expression for VT gets you an achieved. So your achieved is probably in this line here. That's what you need to do to get an achieved. But for a merit, you need to do all that, pretty much that entire extra bit of work there to actually get a merit. I'm going to leave this question up, guys. So I know that there's always people wanting to know certain parts of it. So I will leave this up just for a couple of maybe a minute. So if there's any questions on the chat, let me know. Otherwise, I'll kind of put the next question at the bottom there that you guys can actually have a look at. Okay, so we've got our final question for question 1, which generally tends to be a nice, well, not a nice, but it's just an excellence question. So what we've got here is a kind of like a differential equation, I guess. Water tank developed a leak. 6 hours after the tank started to leak, volume is 400. So first kind of little thing that we're going to write down is that T is equal to 6. Volume is equal to 400. Next it says when 10 hours 256, so T is equal to 10, volume is equal to 256. Now the fourth bullet point where it says the rate at which the water leaks out. Now that first part right there, this part, the rate at which the water leaks out, we can actually call that dV dt, because the volume is changing over time, and that's what that rate at which the water leaks out, rate at which the volume is changing. Okay, and it actually says is proportional to the square root of the volume. So we know that we're going to get square root of volume, but it's proportional, which means it's some kind of constant, and we don't know what that constant is. And so that's what we're going to actually put down here. So that proportional part is where that K comes in, and the square root of the volume is where the square root of V comes from. So in saying that, we have got our differential equation, dV dt is equal to K square root of V. Now this part, what we'll need to do is we can't just kind of go, oh yeah, we're going to integrate V as to the power of half, and it doesn't work like that, because if you think about it, in the denominator you've actually got T, which means, you know, when you integrate this, you're going to get like K square root of VT, which doesn't really make sense. So that's why we've got to bring in all the elements of V to one side, and dt to the other side. So this will actually be looking like this. dv over square root of v is equal to k dt. So if that's the case, we can kind of say that dv over square root of v could be written like this. 1 over x to, sorry, not x, v to the power of 0.5 dv is integral of k dt. So this is what we are going to try and do here. I'm going to try and see if I can squeeze a little bit more out here. So we're going to rewrite this as v to the power of negative 0.5 dv. And k dt, well, if I integrate k, I'm going to get kt plus c. Don't forget the plus c part. I'll kind of carry on here. Now integral of v to the power of negative 0.5. So we've got v to the power of negative 0.5. We're going to go plus 1 to the power divided by the new power, which is that, which is all equal to kt plus c. So we're going to get v to the power of 0.5 divided by 0.5 is equal to kt plus c. Now 1 over 0.5 could be written as 2 root v equals kt plus c. So with that in mind, I kind of forgot one important part, right? The fifth bullet point, which says how much water was in the tank at the start of it when it started to leak. So we're looking for when t is equal to 0, what was the volume there. Now what we've got here is we've actually got a set of simultaneous equations, and it's a good little trick for you guys is that, you know, when you have like 2 bits of information like this, you know you're going to be working with simultaneous equations. So with that in mind, my equation is 2 square root of v equals kt plus c. My first point is 6 400, because t equals to 6 and v is 400. So I'm going to work that out. So I've got 2 root 400 equals k times 6 plus c. Now root 400 is 20, so 20 times 2 is 40. 40 equals 6k plus c. My second one is 10 to 56. So I've got 2 times square root of 256 equals k times 10 plus c. 256 square root is 16. 16 times 2 is 32 equals 10k plus c. Now, I've got these 2 simultaneous equations. If you want to do this the long way, you could do it the long way. You could put it in the, put them top of each other, subtract, and you can do all of that if you want to. But again, for me, it's all about efficiency, right? Like in these kind of things, when I see a simultaneous equation at level 3, I'm not going to be sitting there wasting my time trying to do it manually. If you have a calculator, then just use that straight away. So I'm going to put 6k at 6 and 1. So I'm going to put 6, 1, and the number by itself at the end, which is 40. Then I've got 10, 1, and 32. Just going to solve that. So this is actually telling me that k is equal to -2 and c is equal to 52. So what I've got here is 2 times square root of v equals -2t plus 52. So now I want to know when t is equal to 0 what the volume is. So because t is equal to 0, I am trying to figure out what the volume is. I've got 2 root v equals -2 times 0 plus 52. Then I've got 2 square root of v is equal to 52. Square root of v is equal to 52 divided by 2. Square root of v is equal to 26. And v is equal to 26 squared, which gives me 676. So what do we got for grades wise? Grades wise, E8, right, correct solution gets you an excellence, and this is an excellence question that's actually worth 8 points. Correct general solution to DE plus C not required, so that's an achieved. which would be correct general solution. So you'd have to probably get somewhere here to get to achieved. Merit is getting up to this part here. So yeah, that is pretty much this question here. Right, so question 2a, what we've got is integral of e to the power of 4x, and we've also got integral of 4 to the power of root x. So I'm going to replace that root x as x to the power of half dx, and then we kind of now start integrating. Now integrating with exponential functions, we write everything as is, but we actually divide by the differentiation of the power. So in this case, differentiation of 4x is 4. And then we've got plus 4x to the power of half plus 1. And of course, this is all divided by the new power, which is half plus 1. And of course, we've actually got the plus c. Now, if you want to simplify this, you can actually simplify this further. E to the power of 4x over 4 plus 4x to the power of 1.5 divided by 1.5. Well, 4 divided by 1.5, you can kind of do that in the calculator straight away. And so we can just get rid of that denominator. I think it's like a weird as. Yeah, it is a decimal, but you know what? I want to convert that to, wait, let's just try this. 4 divided by 1.5, 8 over 3. So let's actually do that. So we're going to put that as 8 over 3 plus c. Now, you don't necessarily need to do that as 8 over 3. You could have left it as in that second line as what I did. Plus c is actually not required, so you guys will get an achieved for this particular question, getting up to there. So this question, like I said, I've not seen it in quite a bit of time. But what you can do is when you actually have integrals, right? So when you actually have h of x plus 2 dx, because it's kind of, you can separate it. So what I mean by that is you can actually rewrite this as h of x dx plus between 5 to 1 2 dx. All right, and we already know what this part here is, because this part here is actually worth 6. So we're going to replace this with 6 plus integral of 2 is 2x. So this is going to become 2x, and that's between 5 and 1. So what we're going to get is 6 plus 2 times 5 minus 2 times 1. So we're going to get 6 plus 10 minus 2, which actually gives us 14. So straightforward, there is no negotiations here. You've got to get the answer of 14 for this to get an achieved grade. Okay, so for question 2C here, guys, what I'm going to be doing is, before I actually start with this question at all, one of the things that I like to do is find out what the answer in the graphics calculator is. Because in the calculator, you're going to get the most accurate answer, right? And once you get the accurate answer, as long as you manipulate this integral and write all the necessary things, you can actually get a fairly easy merit. So I'm going to go do this, and I'm going to click on option, and I'm going to go to calc, and there's my integral button. I'm going to click on this integral button, and I'm going to put sine 6x, so sine 6x multiplied by sine 2x. There's my sine 2x. My lower limit is 0, and my upper limit is pi over 8. So shift pi divided by 8. All right, so when I do this, there's my answer right now. So it's 1 over 8. Now, if you just put 1 over 8 here, you are not going to get any grade for it, all right? But what we have done here is we've actually got the accurate answer, the correct answer. So even if you do make mistakes with your integration, or you make mistakes with kind of like putting it in the calculator, it doesn't matter. You've actually got the right answer. So keep that in the back of your head, 1 over 8 as your answer. Now, when we actually have two trigonometric functions and they're getting multiplied by each other, we've actually got a product. We've got to use a product rule here. Well, not product rule, but like that product thing from this particular thing here, which is on your formula sheet. So we've got 2 sine A sine B equals cos A minus B, blah, 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 whatever. All right, so we're going to use particularly this one here. That's the one we're looking at. But we're going to rewrite it a little bit, all right? So we're going to write this as sine A sine B equals cos A minus B minus cos A plus B. And everything is now going to be divided by 2, because all I've done is I've actually taken this 2 here and I've brought it across to the denominator there. Cool. So now that's done, let's get rid of this. Can I still go here? Yep, that's better. So with that in mind, I'm going to start doing the substitution of A and B first. I'm not integrating yet. I'm just substituting A and B. So in this case, I know that A is equal to 6x and B is equal to 2x. So what I'm going to do is I'm going to put down integral of pi over 8 and 2. And I've got here cos A minus B. So that could be written as cos 6x minus 2x minus cos of A, which is 6x plus 2x. And the whole thing is divided by 2. Now, because it's being divided by 2, I can actually take that half out of the integral, like kind of like a similar to a common factor, kind of like a bracket kind of thing, right? So I'm going to take that half out and I'm left with just cos 4x minus cos of 8x. So with that in mind, now I've actually got to integrate it. All right, so now I'm going to integrate it and I've got half bracket. Now integration of cos is sine, so I'm going to get sine 4x. But of course, remember, it's got to be divided by the differentiation of whatever's inside the bracket here, which happens to be 4. And then minus integration of cos is sine. So I've got sine 8x. And of course, I've also got to divide by the differentiation of whatever the bracket is, in this case, which is 8. And all of this is between pi over 8 and 0. Now, here is my lazy trick that I will actually tell you guys, all right? So at this point, what I tend to do is I kind of do this. I go half of, and I actually write this down so I can actually show the marker that I know what I'm doing here, minus sine 8, what is it? 8 times pi over 8 over 8. And of course, I'm going to put this under double bracket, minus sine of 0 over 4 minus sine of 0 over 8. So I do that, but in reality, guys, I'm not going to actually put all of this in the calculator. Why? Because I know what the answer is. It's 1 over 8. So just do that, because that's all you need to do. Because look at the answer schedule. I want to show you guys the answer schedule, right? So check this out. In the answer schedule, they have shown that, you know, they're converting that 6 sine x to the cos x 4x. They've integrated it. Then they've shown a line of substitution, and then they just show equals 1 over 8. Well, guess what? That's what we did as well. We kind of showed it, but this entire part right here that's in, I just realized you guys can't actually see my mouse here, but this entire part, I am not going to waste by actually putting that in the graphics calculator, or any calculator for that matter, because there's a very high chance I could actually make a mistake with that, right? So which is why I kind of just did that whole thing right at the beginning, where I actually worked out what the answer is, which is 1 over 8. And then as long as I get the integration right, then I can just put that as my final answer and I'm good to go for a very easy merit. Yeah, it's not a bad merit question, this one. Yeah, there's my mistake there. Sorry, that should have been a 0 there. Now, interesting thing is, like, look, even though I made that mistake, I kind of rectified it because I knew what I was doing for the end as 1 over 8. And I knew that it was between pi over 8 and 0. So yeah, even though it was a minor error, this would still be getting a full merit grade for it. Yeah, it looks like I made another mistake there. There we go. That should be 0 as well. It's going to be fun for the guys that are actually watching this as a replay. They're going to be like, what the hell is happening here? Sorry, guys. It's just doing two things at the same time. Yeah, talk about kind of messing around here. Okay, so what are we going to get? Correct solution with correct integration is merit. So 1 over 8 is merit. Correct integration, limits not needed, is going to get you an achieved. So a lot of people think that this is the integration part. So you need to be careful, right? You're just rearranging things there. You're not really integrating. Even here, you're not integrating. You're still kind of like just substitution. So in fact, you kind of need to get this part correct to actually get and achieve, because that's where you're integrating. All right, everything else, you're just kind of substituting and kind of rearranging the question. All right, let's go to the next question here. Here we go, question D. All right, guys, so in this question, what we have got is we've actually got 1 over x. All right, if you think about it, like the reason I say 1 over x is because there's x to the power of 1 in the denominator. So with that in mind, we can kind of straight away see that we are going to be using, can't select it, but we're going to actually be using this thing right here, because 1 over x is just ln of x plus c. All right, so with that in mind, what we're going to do is we've actually got integral of k and 2, 6 over 3x minus 4 dx. All of this is equal to 4. All right, that's what the question actually says, and we're trying to figure out what k is. Now, some people are saying, yes, James, you could actually you could do u substitution, but in this case, what I'm going to do is I'm just going to do it straight up, man. It's ln. So I've got 6 ln of 3x minus 4. Don't need to worry about the plus c because we got definite integrals, but there's one part that we do need to remember. We actually have to divide by the differentiation of whatever's inside this bracket. Now you can have a look at it, and in this case 3x minus 4, the differentiation of 3x minus 4 is 3, so we're going to put that here, and that's between k and 2, and this is equal to 4. All right, so what do we have? We've got 6 divided by 3, which is 2, so we've got 2 ln of 3x minus 4, and that's between k and 2, which equals to 4. So now we're going to substitute k and 2. So we're going to get 2 ln of 3k minus 4 minus 2 ln of 3 times 2 minus 4, and all of that is equal to 4. Just want to double check if I'm actually on the right track. Yep, everything's looking good. So we've got, I'm going to take 2 out as a common factor, which means I'm going to get ln of, I'm going to put this as 3k minus 4 minus ln of 2 is equal to 4. So with this in mind, I'm going to take 4 to the other side. And when I take 4 to the other side, I'm going to get ln of 3k minus 4 minus ln of 2 is equal to 4 divided by 2. And I'm going to get 2. So in that case, I've got ln of, I'm going to change this bracket, but I hate writing it in absolute value, but yeah, it is what it is. Equals 4 divided by 2 is 2, and I've got plus ln of 2. Okay, now I just need to figure out what k is equal to, right? So I'm going to take exponentials for both of these things. So what I'm going to do is put it as e to the power of on both sides. So remember, e and ln cancel out each other. So what I've got here is 3k minus 4 is equal to e to the power of 2 plus ln of 2. All right, next thing, I'm going to add plus 4 to it. So I've got 3k is equal to, can I do this any further? I'm trying to make it easy, but you know what, let's just do it this way, it's fine. I mean, I could do e to the power of 2 plus ln of 2, I can get rid of it, but that's alright, I'm just going to leave it as it is. And I've got plus 4, and then k is equal to e to the power of 2 plus ln of 2 plus 4, and the whole thing is divided by 3. I'll put that plus 4 in red so you guys can actually see what's happening. So I could actually leave my answer like this, because in the answer schedule, which I'm going to show you guys very shortly, there you go, you can actually leave your answer like that, 2e 2 ln of 2 plus 4 over 3, or you can actually write the final answer, which is 6.26 as well. So either way is fine. Grades wise, I mean, I would have actually just left it like this, which means I'm going to get a merit for it. Correct integration is going to get you an achieved, so that is this line here is going to get you an achieved. So again, for this question, I could have actually done it in the calculator to figure out what K is, but at level 3, they don't mind you leaving your answers in exponential form and ln form. So keep that in mind as well, all right? Just saves a bit of time when you're working with a merit question. Okay, so what we have is we do have a differential equation for this particular question here. So I'm going to actually kind of bring all the elements that I want and the ones that I don't want on one side. So in other words, I'm going to cross multiply, and this is going to end up looking like y dy equals 2 over e 0.5x dx. Now I need to integrate both of these symbols. So when I actually integrate both of these symbols, a good help is that bringing that e to the power of 0.5x to the numerator. So I'm going to get y dy is equal to integral of 2e negative 0.5x dx. So now I'm going to integrate the functions. So on this side, I've got y squared over 2 equals, when you integrate exponential functions, you write everything as is. So 2e negative 0.5x. But of course, you got to divide by the differentiation of whatever the power is, which in this case is negative 0.5. And of course, we've got to put the plus c, all right? We have to put the plus c in this. So I've got y squared over 2 equals 2 divided by negative 0.5 is negative 4. So negative 4e to the power of 0.5x plus c. Okay. So this part right here is going to get you an achieved, all right? And again, C is actually not required to get the achieved. So just this part is going to get you an achieved. Now the next thing is we do need to work out what C is. And the way we're going to do it is we're going to use this point right here, which happens to be 0, 1. Maybe I should just get rid of that. Yeah, 0, 1 is what we're going to use. So in here, I've got 0 and 1. So y squared, so y is equal to 1. So I've got 1 squared over 2 equals negative 4e negative 0.5 times 0 plus c. So 1 over 2, that's just 0.5 equals negative 4. And then e to the power of 0 is just 1 plus c. So then c is equal to 0.5 plus 4, which gives me a c value of 4.5. So my equation is y squared over 2 equals minus 4e negative 0.5x plus 4.5. So if you get up to this part, you actually get a merit. Now to get that excellence, all we got to do is work out the distance between P and Q. Now what happens is if I actually substitute 3, I'm going to get a y value, which is the yellow part. And then if I want to get the distance between P and Q, I need to double that yellow part there. And of course, x is equal to 3. So I'm going to go here and I'm going to say y squared over 2 equals negative 4e negative 0.5. And I've said 3 plus 4.5. So I've got y squared over 2 equals, let's actually work all of this out in the calculator. What do we got? So negative 4 multiplied by e to the power of 3 times negative 0.5 is negative 1.5 and plus 4.5, which gives me this number here, which is whatever this is, 3.6074. I'm just going to leave it like that. Then y squared is equal to 2 times 3.6074, and then y is equal to square root of whatever this number is. Now, of course, the reason I'm putting this is because I'm just going to do the multiplication here. So I'm just going to go times 2, and then of course I'm going to take square root of this right here, which actually gives me y is equal to 2.686. Therefore, distance of PQ is equal to 2 times 2.686, which actually equals to 5.372. Yeah, let's go with that. Yeah, and the final answer there is going to get you guys the excellence grade. It's actually pretty nice little excellence question, to be honest. I mean, for the amount of time it actually took us to solve that, you know, especially if you are quite comfortable with what do you call it, differential equations, then you can get this excellence question in no time. It's not a bad one for this paper. So we've got question 3A here. With question 3A, the first thing you really want to be doing is expanding the brackets, because we've got that square root of x that we need to deal with. So I'm going to have x plus square root of x times x plus square root of x. Then I'm going to actually do expansion of a quadratic. So I've got the first terms, the outsides, the insides, and the last terms. So what I've got here is x squared. Now x times x to the power of half can be written as x to the power of 3 over 2, because x to the power of 1 plus x to the power, like, times x to the power of half. So 1 and half makes 1.5, or 3 over 2. We've got another 3 over 2. And plus square root of x times x is just going to be x. So what we have here is x squared plus 2x to the power of 3 over 2 plus x. And of course, we have got to integrate this. Now, in saying this, like, this is just expanding the bracket, so there's actually no grades here so far. X squared integrates to x cubed over 3 plus 2x to the power of 3 over 2 plus 1. And of course, that's going to get divided by the new power, which is 3 over 2 plus 1. Of course, I've got to put that 3 here. And of course, we've got plus x squared and the new power divided. So we've got to divide by the new power, which is going to be 2, and plus c. Now I'm just going to tidy it up a little bit. You can kind of leave it to a degree. You can kind of leave it like this. But yeah, you know, tidying it up is always a good idea. So I might even put like a little bracket here. That's pretty much it, guys, and that should get you an achieved. If you do want to tidy up that middle term, you can, because you're going to end up with x cubed over 3 plus 2x, 3 over 2 plus 1 is 5 over 2. You've got 5 over 2 plus x squared over 2 plus c. Of course, you're really wasting time, you know, by actually doing this. So we're kind of gonna, I mean, I'm just doing it because I know sometimes people are like, why is this, how does this answer actually work? So the 2 comes to the top. We've got 4x to the power of 5 over 2 over 5 plus x squared over 2 plus c. But really, all you need to get up to is that part there to actually get an achieved. So as I mentioned before, trapezium rule, you've guys got to, it's just a matter of substituting the right things, all right? So what we're going to do is we're going to write that equation down first. I've got b and a. So in this case, b is equal to 2.5 and a is equal to 1. So put those two things there. And then it's approx f of x dx, yeah, whatever. F of x dx is equal to half h. Now, if you guys have a look at it, h is pretty much that, like, what the interval is, right? So if you go 2.5 minus that is 1.5, and then divide it by 1, 2, 3, 4, 5, 6. So it's about 0.25. So h is equal to 0.25. Because, like, n is the number of gaps that you actually have between them, and you can see that there's actually 1, 2, 3, 4, 5, 6 gaps. So h is equal to 2.5 minus 1 divided by 6, all right, which equals to 0.25. We already kind of can see that here because everything is going up by 0.25. So that's what h is going to be. So that's going to be 0.25. And then what we've got is y0. So this is going to be y0, y1, y2, y3, y4, y5, and y6. Every time I say y5, I always have a good little laugh. But all right, what's y0? y0 is 0.8 plus yn, which is y6 in this case, which equals to 2.4, plus 2 times everything that is remaining. And of course I ran out of space. That's okay. I'm gonna try to carry it here. Plus 2 times 1.1 plus 1.5 plus 1.9 plus 2.2 plus 2.1. So just a matter of putting this in the calculator, guys. I guess I just need to get rid of this. I don't really need this screen anymore. Or do I? I'll use it later. So putting this all in the graphics calculator at the moment. So what I've got is 0.5, 0.5 times 0.25 times bracket 0.8 plus 2.4 plus 2 times 1.1 plus 1.5 plus 1.9 plus 2.2 plus 2.1. First bracket, second bracket, that should be done, and I get an answer of 2.6. I mean, if you look at it, I nearly worked on this question for 3 minutes. For an achieved, for this 3 minutes is not worth it. Like, I would almost say go and have a look at the merit question and see if you could rather spend that extra 2 minutes in the merit question. Because in this question, right, you make one minor mistake and you don't even get the full achieved. And that's what's so frustrating about these trapezium rules and Simpson's rule questions. And every year they have one of these questions. And every year I say the same thing. I hate them, and just skip that question and go straight to merit. Unless you're like, man, I just want to pass this paper, then make sure you get this question correct and double check your answers, all right? Okay, so with question 3C, what we've got is a differential equation. So with differential equations, the first thing you really want to be doing is you want to bring all the y's to one side and all the x's to the other side. So what we are talking about is we've got dy dx equals sec squared 2x over y. Cross multiply this, so we're going to get y dy equals sec squared 2x dx. All right, with that in mind, we're going to integrate both sides. When we integrate y, we're going to get y squared over 2. Now when we integrate sec squared x, you're going to get tan x, or in this case you're actually going to get tan 2x. But of course, remember, you have to divide by the differentiation of whatever the bracket is. So in this case it's going to be 2, and of course it's a differential equation, so don't forget the plus c. Now doing it up to this part in this particular question is actually going to get you an achieved. So let's go and try and figure out what we need to do to get a merit. Now it says, given that y is 2 when x equals 3 pi over 8, find the values of y when x equals to pi. So it's a two-stage question, right? So the first stage is we actually need to figure out what c is. To figure that out, we actually have the x and y value, because our x value is 3 pi over 8 and our y value is 2. So we're going to use this first to try and figure out what the c value is. So our equation is y squared over 2 equals tan 2x over 2 plus c. Now y is equal to 2, so we've got 2 squared over 2 equals tan 2 times 3 pi over 8 over 2 plus c. Now 2 squared over 2, that's 4 over 2, so we're going to get 2 equals, now tan 2 times 3 pi over 8. I kind of need to do that in the calculator. So making sure that your calculator is actually in radians. So we're going to go shift setup, check that the angle is in radians. Good, that's fine. Next up, we're going to go, let's just get rid of all of this. We're going to go tan of 2 times 3 pi over 8. Cool, so that's actually equal to -1. So what I've got here is -1 over 2 plus c, and if I rearrange this, I'm actually going to get c is equal to 2 plus a half, so we can say that c is equal to 2.5. Now once we figure that out, next step is to actually substitute x into the equation. So our equation, well, x is equal to pi, we need to figure out what y is. So we've got y squared over 2 equals tan 2 pi over 2 plus 2.5, because 2.5 is the c value. So with that in mind, I've got y squared over 2 equals tan of 2 pi. So tan of 2 pi is equal to 0. So we've actually got 0 plus 2.5. So y squared is equal to 2.5 over 2. Cross multiply, I've got y squared equals 2.5 multiplied by 2, which means y squared is equal to 5. So therefore I can say y is equal to plus or minus square root of 5. Now it's really important that you put that plus or minus, just because I know in the answer schedule they actually say plus or minus not required, but when you're working with calculus, especially at this level, it's just good habits to kind of put that plus or minus in, because certain questions you're going to get where you're going to need to use that plus or minus. And so it's always a good habit that when you take square root of a number, you actually put down plus or minus. So getting to that final answer is going to give you a merit. Correct separation of both sides. Yeah, so that's pretty much it for this question, guys. That's a merit question, and you need correct solution with correct integration after correct separation of both sides. A lot of things happening there. But yeah, that's what you're getting for a merit. All right, so with this question, guys, what we need to do is we actually need to figure out what the two x intervals are. And like I said, you really don't want to be wasting time trying to substitute y and then rearranging x and all of that. Go straight to the graphics calculator and pull out the points. How do you do this? You go into menu, click on graph, and we're going to actually plot this graph. So in this case, we've got 3x minus 2, and that's divided by x plus 2. So there's the graph. So what you can do is you can click on gsolve and go into this little F6 button, which gives you further options, and you can actually do something called xcal. So xcal basically means it'll ask you for the y value. So I'm going to put down 1, and as you can see, the x is equal to 2. Then I'm going to do an xcal again. So gsolve F6 xcal, and this time I'm going to put y is equal to 2. Press enter, and that's giving me x of 6. Okay, so as I said to you guys before, I don't like to waste time with these types of questions. What do I mean by that? I want to know what my answer is already, right? So I'm actually going to do that first in the calculator. So I'm going to go to run menu, the original, just the normal one, and I'm going to go to option, calc, and I'm going to click on integral, and I'm going to put this integral straight away. So I've actually got 3x minus 2 divided by x plus 2. And my two intervals are between 2 and 6. So when I actually do this, I get 6.455 as my answer. All right. So with that in mind, I'm going to keep that in the back of my head, or actually just leave it in the calculator, because I know that's what my final answer is going to be. All I need to do now is just to show the integration aspect of it. So I've got 3x minus 2 over x plus 2 dx. And this is between 6 and 2. So as I said to you guys before, you guys can actually do long division for this, or you could do u substitution. Now I'm going to do long division because it's literally one step here. So I've got x over 2 and 3x, x plus 2 and 3x minus 2. I've got to multiply by 3. So 3 times x is 3x. So that's that. And then 3 times 2 is 6. Which happens to be that. Now I need to subtract. So 3x take away 3x is 0. Negative 2 take away 6 is negative 8. So what I can actually then do is I can rewrite this as integral of 6 and 2. And I'm going to get 3 minus 8 divided by, actually I might actually do it like this. 3 minus 8 over x plus 2. dx. So the next part is I need to integrate 3, and I'm going to get 3x. Negative 8 over x plus 2 will integrate to 8 ln of x plus 2, and I don't have to divide, like I don't have to worry about any denominator because x plus 2, what I mean by this, differentiation of this is 1, so that's why I don't really need to worry about it. And I know that this is between 6 and 2. So what I've got is 3 times 6 minus 8 ln of 6 plus 2 minus 3 times 2 minus 8 ln of 2 plus 2. Of course, I'm not going to actually put this all in the calculator because I already know what the answer is and I've already worked it out. So I'm just going to put that as 6.455. Grades wise, this final answer is worth a merit, and correct integration is actually worth achieved. So you need to get to this line here to actually get an achieved. All right. So last question for this particular paper, guys, and also for us. Okay, so what do we got? We've got both of these curves here. First curve is this yellow one here that's going to go like that. So that's our yellow curve there. Then we've got y equals k, which happens to be here. Now what we can kind of assume is, because that's the origin there, we know that this part right here is going to be equal to 0. And here we go, the customary dog bark will be happening very shortly. But we actually need to figure out what this value is. So to figure out what this value is, we actually need to put both of these equations equal to each other. So we've got kex squared equals to k. And then, yeah, we pretty much leave it like that and we try and figure out what x is equal to. So I've got k squared e to the power of 2x equals k, because, you know, when I do powers of powers, remember that k has a power of 1. And what do we need to do next? We're going to get rid of the k squared to the other side. So e to the power of 2x is equal to k divided by k squared. So in other words, you're going to get e to the power of 2x is equal to 1 over k. So far, so good. Next, we need to work out what the take logs for both sides. So we're going to get ln of e to the power of 2x equals ln of 1 over k. Now ln and e kind of disappears, so we're going to get 2x is equal to ln of 1 over k, and then we can say that x is equal to ln of 1 over k, and the whole thing is divided by 2. So all we really discovered here is just this particular point, ln of 1 over k over 2. And unfortunately, this gets you nothing because you've actually done no integration. All you've done is just put two equations together to get an x value. So, you know, even if you get up to this part, you don't actually get an achieved. You can get an achieved for integration of the equation, but like we'll do that next, right? So we can actually work out the area because we've got the two zones here. We can actually do the whole between 0 and ln of 1 over k over 2. Now, I don't know if you guys have actually watched some of my videos. We do the whole top minus bottom to find the area between two curves. So that's what we're going to do here. So the top is the yellow line, which is going to equal kex squared minus k dx. All right, so with that in mind, now we need to actually kind of expand that bracket before we kind of do anything further. So we've got 0 ln of 1 over k over 2. We've got k squared e to the power of 2x minus k dx. All right, so let's integrate this. Now k squared is a constant, guys, so we don't need to worry about it. It is still going to be k squared e to the power of 2x. But of course, I've got to divide by the differentiation of the power, which happens to be 2. And then I've got minus k, which integrates to minus kx. Now all of this is between 0 ln of 1 over k over 2. So I'm hoping it's good so far. Now in terms of grades, I think by the looks of it, if you were to get correct integration is going to get you an achieved. So this line here is going to get you an achieved. Correct integration with correct limits substituted in is going to get you a merit. So the next line, you're actually going to be looking at a merit, because you got k squared e to the power of 2 times 0 over 2 minus k times 0 minus, now here's when things are going to get really quite ugly here. So we've got k squared e to the power of 2, x is equal to ln of 1 over k over 2. All of this is over 2 minus k times ln of 1 over k over 2. So just want to check that I've actually got everything right here, because between 0 and ln of k over 2, everything is looking good so far. Right, so what do we got here? E to the power of, let's kind of start getting rid of some of these elements. So we've got e to the power of 0, which equals to 1. So we've got k squared over 2 minus k times 0 is 0, so that's fine. So we've got minus. Now here we've got k squared. Now the two 2's cancel out each other. I'm talking about these 2's here, which means I'm left over with e to the power of ln of 1 over k over 2 minus k over 2 ln of 1 over k. At this point, I've got k squared over 2 minus, in the bracket, I've got k squared over 2. Now e and ln cancels out each other, which means I'm going to get multiplied by 1 over k minus k over 2 ln of 1 over k. So next I'm going to expand, get rid of the k squared and k, which is here. So I'm going to end up with just k over 2 minus k over 2 ln of 1 over k. Keep carrying on. So I've got k squared over 2. I'm going to take out the brackets. So I've got minus k over 2 plus k over 2 ln of 1 over k. Now my proof should be, what's my proof? My proof should be, I'm doing this here right now. It should be k over 2 bracket k minus 1 plus ln of 1 over k. So all I got to do here is take k over 2 as a common factor. Then I'm going to get k minus 1 plus ln of 1 over k. I have to say, like, I mean, I know it's quite ugly in terms of like lots and lots of substitution here, but you actually get merit at this point right here just for substituting. And then by the looks of it, if you get the final part, correct solution with correct full equations, sorry, correct solution with steps clearly shown, gets you an excellence there. So it's actually not a bad question, to be honest, and I think about all 3 excellence questions that popped up in this paper, it's not too bad. Like, I mean, you could have actually attempted the excellence question straight away for those high risk guys. Yeah, it is possible to actually get those 3 questions and then be off on your merry way with 24 points. There you go. That's basically it for this question, guys, and I think that's us.
Hey guys, that is basically it for this video. As always, don't forget to like this video, share this video, and of course subscribe to keep up with the latest content. There should be some playlists popping up. Check them out. Great revision material. And as always, thank you for watching.